Hi everyone, the continuation of Laplace transform. So the second problem, Laplace transform of e power minus at. We are going to do this problem. Find the Laplace transform of e power at. So solution for this problem, what is first, right? Laplace transform. What is Laplace transform of t? Laplace transform of function of t, which is equal to integral lower limit 0, always upper limit infinity, e power minus st f of t dt. So this is the formula. Laplace transform formula, Laplace transform of f of t is integral 0 to infinity e power minus st f of t dt. So after writing this formula, apply the function is here e power at. So integral 0 to infinity e power minus st f of t is here e power minus at and dt. So next step, you have to take integral 0 to infinity, you have to take negative out. So if you are taking negative, and this is s plus a, taking t also out, integration with respect to t. That's what. Why I am taking negative out? Because e power infinity minus infinity is 0, e power infinity is infinity. That's what. Always if you want to make one function 0 means always take minus infinity outside. So similarly anything per 0 is 1, that you know very well. So now what is integration of e power ax into dx? E power ax integration e power ax divided by a, the same concept. E power integration with respect to t, this is integration with respect to x. So e power ax integration, again e power minus s plus a into t, the coefficient of t is minus of s plus a divided by minus of s plus a, and the limit is given, the lower limit 0, upper limit is infinity. Correct? Lower limit 0, upper limit is infinity. Apply the limit. Before applying the limit, take minus 1 by s plus a outside, then the remaining e power minus of s plus a into t, limit 0 to infinity. First, why I already told you, why taking negative out? Because e power minus infinity is 0. That's what. S plus a, and apply the limit. Instead of t, you are applying the limit infinity. So infinity into anything, infinity. So e power minus infinity minus e power 0. Right? E power minus infinity, e power 0. So this will be minus 1 by s plus a. E power minus infinity is 0. 0 is 1. Anything power 0 is 1. So negative into negative, this is positive. So minus into minus plus. So this will be 1 by s plus a. 1 by s plus a. Now tell me, Laplace transform of e power minus at. Answer is 1 by s plus a. So next we'll see the one more next question. Third one, Laplace transform of, find Laplace transform of e power at. So first we completed e power minus at. Now we are going to do e power at. Solution for this problem, write a formula. So what is the formula? Laplace transform of f of t is equal to integral 0 to infinity e power minus st f of t into dt, function into dt, integration with respect to dt. 0 to infinity e power minus st, the given f of t, the given f of t is e power at. Replace f of t by e power at into dt, e power at into dt. So next step, take negative out, that is very important. Integral 0 to infinity, taking negative out. So this will be s minus a times t into dt, s minus a times t into dt. So which is equal to, integrate this like previous problem, e power ax integration e power ax by a. So e power minus s minus a into t divided by the coefficient of t minus of s minus a, and apply the limit 0 to infinity. So before applying the limit, you just take outside minus of 1 by s minus a outside. So upper limit is infinity, so e power minus infinity, lower limit is 0. you know, e power minus infinity is 0. So minus of 1 by s minus a, this will be 0 minus 1. So minus into minus plus, the answer is 1 by s minus a. So the Laplace transform of e power at, the Laplace transform of e power at is 1 by s minus a. So you just keep a mnemonic that e power at means positive at means that opposite sign will come, e power s minus a. E power minus at formula, Laplace transform of e power minus at formula, opposite symbol. So 1 by s plus a. So recall both formula. First one we did Laplace transform of 1. Laplace transform of 1 is 1 by s. Laplace transform of e power at and e power minus at we have completed. Next, the next one is we are going to see Laplace transform of sin at and cos at. Next, we are going to learn find. This is your fourth question. Find Laplace transform of sin at and cos at. Both together we are going to learn sin at and cos at. So this one, we know that Euler's formula, right? Using Euler's formula, we are going to solve. Let us consider the Euler's formula. Euler's formula, e power I theta. So how to write e power I theta? Cos theta plus I sin theta. You know this formula, right? Cos theta plus I sin theta. I am going to take theta is equal to at because we are going to find out sin at or cos at. Substitute theta equal to at. So uh, e power theta value is 80, correct? Theta value is 80. So I into 80, which is equal to cos 80 plus I sin 80, correct? And I am going to reverse the process. Left side I am going to write this as a left side and this as right side. So this will be cos 80 plus I sin 80. Cos 80 plus I sin 80 is equal to e power I 80. So this one we are not going to apply Laplace transform directly. Instead, taking Laplace on both sides. Taking Laplace on both sides. So once you take Laplace on both sides, what you will get? So which is equal to Laplace transform of cos 80 plus I sin 80 equal to Laplace transform of e power I80. Actually, what is your Laplace you know that Laplace transform, right? Laplace transform of e power 80 formula 1 by s minus a, correct? 1 by Laplace transform of e power 80 formula 1 by s minus a. The same thing we are going to apply left side right as it is. Laplace transform of cos 80 plus I sin 80, right as it is. And right side what we are going to do, Laplace transform of sin e power 80 formula 1 by s minus coefficient of t. So s minus ia. So it is a complex number. Always don't keep the I letter in the imaginary part in the denominator. That's what you have to multiply and divide the conjugate. So s plus conjugate of s minus ia is s plus ia. So I can write 1 by s minus ia into s plus ia divided by s plus ia, right? So denominator a minus b into a plus b. So a square minus b square. Numerator s plus ia by the denominator a square minus b square. A square minus ia the whole square. A square minus b square ia the whole square. So which is equal to s plus ia. You know I square is equal to 1, right? It's a complex number. I square is 1. So it's a positive I square equal to minus 1. So this minus a square, right? So which is equal denominator by a square plus a square will come. Minus into minus positive. So a square plus a square. So I can rewrite this again, which is equal to left side you have Laplace transform of sin 80 plus, you know, this is formula. Left side you have Laplace transform of cos 80 plus I sin AT, correct? Cos AT plus I sin AT. Laplace transform of cos AT plus I sin AT. So you write the same Laplace transform of cos AT plus I sin AT, which is equal to, I am going to split the function, numerator s by s square plus a square. So similarly the imaginary part I times a by s square plus a square. What I am going to do next step is just comparing the real part and imaginary part separately. Next one, comparing real parts and imaginary part. So once you compare real part and imaginary part, so what you will get? So the real part is cos AT, right? So Laplace transform of cos AT, which is equal to, here the real part is this, s by s square plus a square. So s by s square plus a square. Now this is the formula. So similarly imaginary part is coefficient of I. So Laplace transform of sin AT, which is equal to I oda coefficient, so which is equal to a by s square plus a square. Now understood the formula. Laplace transform of cos AT is s by s square plus a square. Laplace transform of sin AT is a by s square plus a square. So this is the problem. Find Laplace transform of sin AT and cos AT. This is your fourth one. Next we'll go for fifth one. Fifth one, find Laplace transform of sin HAT. Sin HAT. This one also we are going to consider. Let us consider. We don't have direct formula. Instead, we are not going to apply in a direct formula. Instead, you have a hyperbolic function, right? Sin HX. Sin HX, you can write sin HX is e power x minus e power minus x divided by 2. Correct? So similarly you have cos hx. Cos hx is also e power x plus e power minus x divided by 2. So keep in mind. So now we are going to write sin hat. The value of x is 80 and this will be e power 80 minus e power minus 80 divided by 2. So similarly here cos hat. So you can write e power 80 plus e power minus 80 divided by 2. So this is the formula, right? This is the hyperbolic function formula. Now we are going to solve the problem. Laplace transform of sin HAT. Laplace transform of sin HAT, which is equal to taking Laplace on both sides. Here you just taking Laplace on both sides. Laplace on both sides. So Laplace transform of sin HAT equal to Laplace transform of e power 80 minus e power minus 80 divided by 2. Right? By linear property. You know Laplace transform holds the linear property. Take 1 by 2 outside and you can write Laplace transform of e power 80 minus Laplace transform of e power minus 80 and the other function is e power minus 80. You know Laplace transform of e power 80 is opposite symbol, right? So 1 by 2, 1 by s minus a. This is negative 1 by s plus a, correct? And just simplifying this equation, you will get the answer, which is equal to 1 by 2. Do the cross multiplication. So s plus a negative minus s plus a divided by denominator s, a minus b, a plus b formula. So a square minus b square. So s square minus a square. So here what is cancelling? S cancelled. So which is equal to 1 by 2 and numerator 2a times s square minus a square. Again I am just cancelling the 2, numerator 2 and denominator 2 you are cancelling. And finally what you are getting? Laplace transform of sin HAT is equal to a by s square minus a square. Similarly if you follow for this, taking Laplace on both sides and applying the same concept, you will get Laplace transform of cos HAT. You try this problem, okay? cos hat is equal to, what is the formula? Cos means numerator s by s square minus a square, right? So sin hat a by s square minus a square, cos hat s by s square minus a square. So similarly, Laplace transform of t power n, you know, formula t power n already we discussed, right? N factorial by s power n plus 1. Okay, so just revise all the formulas for doing the other problems. Thank you.